the fundamental counting principle, one of the most fun things we can do here in math, and why we need this. So let's consider the example. I want to buy a new car. I know exactly what I want to buy. Let's say I want to buy a Honda Accord. Doesn't really matter, but I go to the dealership and they're like, well, we have that car in 12 colors, 2 different transmissions, 2 different engines, 16 accessory options, 4 possible upgrades, and 3 tire options. Which car would you like? How many car options do I have? Right? I just wanted a Honda Accord, right? But we have all of these options. So the fundamental counting principle says, if the first event has 8 possible outcomes, like 12 colors for a car, and the second event has B possible outcomes, like 2 transmissions, and the third event has C possible outcomes, like 2 engines, well, we could say the total possible outcomes is found by multiplying 12 times 2 times 2, right? We multiply those things together, and it doesn't matter how many we have. We simply multiply all of our possible outcomes together, and that gives us our total number of outcomes. Now, this does assume that we're only taking 1 from each category, okay? So back to my car. We've got all of these different things. So if I take just 1 from each section, including the accessories, right? So maybe I'm getting the hitch on the back, but I'm not getting the carrier on the top, whatever. Just 1 accessory, the other ones kind of just make sense. But I multiply them all together, 12 times 2 times 2 times 16 times 4 times 3, and I get 9,216. So with these options, I have 9,216 different options for cars. It's so many. That's a lot. How do I decide? Well, if you say, well, I definitely know that I want an automatic. Well, great. Then that takes a little bit out of it. But if you're really open to all the options, that's a lot. Let's go to my closet. This is a little bit more fun. And I had to pare down the actual numbers because nobody really wants to know how many pair of socks I own. And let me tell you, it's way more than 32. So I have 4 pair of pants, 14 shirts, 32 pair of socks, and 3 pair of shoes. I have way more shoes than that too. How many different outfit combinations could I have? Now we're also going to assume that everything goes together, right? We're just going to pretend. So I can mix and match all of these different things, right? So we multiply my 4 pair of pants times 14 shirts times 32 pair of socks times 3 pair of shoes. And I would have 5,376 distinct outfits out of that closet alone. So if you would say like, well, how many items do I really have in my closet? I don't even want to know the answer of how many different outfit combinations I could have because it's crazy. It's crazy, but it's kind of fun to think about. Now let's do one more talking about factorials, okay? So this is slightly different, but it still falls under the counting principle umbrella. Now, 5 friends go to a movie and they want to know how many ways they can decide where to sit in the 5 seats. So if you think about it, there's 5 friends and there are 5 seats and they're like, well, who's going to sit in that first seat? Well, we have 5 options, right, of who's going to sit in that first seat. And then Elizabeth sits down. So now I have 4 friends and 4 seats. Well, now we have 4 options for that second seat. And then Katie sits down. And now I have 3 friends and 3 seats. And then Tony sits down. And then I have 2 seats. And then Meg sits down. And then the last person sits in the last seat. And we use this by saying 5 times 4 times 3 times 2 times 1. So because 5 people have an option for that first seat and 4 have an option for that second seat, this is what we call factorial, right? This would be 5 factorial, which is 5 with an exclamation point. And that simply means you start with 5 and you multiply down by decreasing by 1 all the way to 1. So we would have 120 different ways of sitting those 5 friends down in those 5 seats. So again, just kind of something fun as we're working through the fundamental counting principle.